go. So I'm saving this into today's zip file. You can download the zip file at the end of the class, well, as soon as I upload it, and it should be a part of the zip file. And then we'll go ahead and trace the code. There are several test cases you have to trace with this program, so don't forget to trace all of the test cases. Here's one, there's another one, and here's the third one. So there are 3 test cases to trace. We'll deal with the first one first. We start execution on line 1, and B gets initialized to 0. Then we go to line 2. Bar A bar, if I look at it, is 4. So E becomes 3 because it is bar A bar minus 1. Then we go to line 4. Line 4 is calculating what is B plus E divided by 2, and then we take the floor function of that. B is 0. E is 3, B plus E is 3. 3 divided by 2 is 1.5. The floor of 1.5 is 1, so M gets a value of 1. We then move on to line 5. Line 5 is a comparison. It's comparing A bracket M with K. K has a value of 3. A bracket M is A bracket 1 because M equals to 1, and it has a value of 2. 2 is less than 3 is true. Yep, go ahead.
How come we never compare it to A bracket 0?
Because this is binary search, we start from the middle.
Okay.
We start from the middle. If I specify K to be -1 or 0, we will compare to the element at 0. It's just that because of the value of K, we are not going to touch it.
Okay.
Which is why we use binary search, because at this point, because I know that A bracket 1 is less than K, I don't even need to bother with A bracket 0 because the array is sorted. Okay, that's a good question. It really helps to re-explain why binary search is so efficient. It's because once you compare to one element, you can infer about the elements either to the left or to the right of that one. Yep.
Is there a reason we didn't compare? I mean, we did compare K to A bracket M, but we didn't do it the other way around with K is less than A bracket M.
Because if this one is true already, there's no need to compare it, in the opposite way.
I was just wondering, in the other trace, we did the other one first. I was just wondering if there was a reason.
The order of A bracket M versus K, whether we check for less than first or greater than first, is completely arbitrary.
Okay.
Yeah, so there's no particular reason one way or another.
Okay.
Yep. Mm-hmm. But since the condition is true on line 5, we go to line 6. Line 6 is going to update B. So B will be updated to become M plus 1. M has a value of 1 at this point. 1 plus 1 is 2. Is that okay? After line 6, we are done with the conditional statement, because this is a conditional statement. If we execute one branch, then we are done with the entire conditional statement. Then we go to line 10. Line 10 is asking A bracket M equals K. That's false. Okay? But because this is a disjunction, I cannot get out yet. I cannot just say, okay, we are done, because if the first condition is false, I have a second chance to make a disjunction true. So I have to look at the second part. The second part is asking, is E less than B? The answer is no, because E is 3, B is 2, so B is not less than B. We have false or false in this case, which means the entire thing is false. Are we doing okay so far with the construct, with the loop construct? If the condition of a repeat until loop is false, we have to perform the iteration again. So we go back to line 4 and do the whole thing again. But this time B is 2, E is 3. 2 plus 3 is 5. 5 divided by 2 is 2.5. the floor of 2.5 is 2. So that means m, in this case, will become 2. Then we go to line 5 again. Line 5 is still asking the same question. A bracket m is less than k. Is it true or is it false this time?
False. Not true.
Okay, m is 2. A bracket m is a bracket 2. Has a value of 4. 4 is less than 3 is false. Okay, so this is false. That means we do not go to line 6. We have to go to line 7 to look at the other condition. The other condition is k is less than a bracket m, and obviously that one is true. So we go to line 8. Line 8 is going to update e. E will be updated to become m minus 1. M is 2 at this point. 2 minus 1 is 1. So e is now updated to 1. And then we go to line 10. Line 10 is still asking a bracket m equals k, and that is still false. However, e is less than b is true. False or true is true. We get out of the loop. We go to line 11. Line 11 looks kind of mysterious, but if you just apply what you know about assignment statements and comparison, it is something that we should know how to do. Because this is an assignment statement because of the left arrow symbol, which means we evaluate the right-hand side, whatever it is, will become the value of the variable on the left-hand side. The right-hand side is a comparison. A bracket m equals k is a comparison. It's either true or false. In this case, it is false. Yep.
When you do the code down in pseudocode, how would you say f, since you get an equal, and you're saying f is equal to a bracket m is equal to k, is there use double equal signs or single equal signs if you actually use it in code?
If you do it in C, you have to use the double equals symbol.
Okay.
Yep. Okay, so you have to be very careful because in this class, we do not use a single equal symbol to mean assignment statements, which is the way C works. Okay, C uses a single equal to mean assignment and a double equal to mean comparison. Okay, and it does allow you to use an assignment inside the condition, and you can also specify a comparison outside of the context of a condition. Okay, so that means you can interchange. You can really use an assignment operator when a comparison operator is expected, and also vice versa. Are you looking for the chair? Okay. So that's why in C you have to be very, very careful when it comes to the use of the single equal versus the double equal symbols, because they can be used where you do not think it is applicable. Now in Visual Basic, they use a single equal to mean both assignment as well as comparison. But it's not a problem because you cannot put an assignment operator inside the condition of a conditional statement. Or you cannot use a comparison outside of the context of a comparison. Okay, so VB is a little bit different, but in this case, since we use this operator or the left arrow as a symbol for assignment, we don't have that problem. But you are right; you have to be careful if you're using C and C++. Okay, so the right-hand side evaluates to false in this case, so we update f as a variable to become false. That's the end of it. Do we have any questions about the first trace, the first test case of the homework assignment?
So even if it was the case that a bracket m equals k, it would just be true. We don't put an actual number in there.
Not the actual number, just true. Yep. Because the right-hand side is an expression that returns either true or false. So whatever that is, we put it inside the variable on the left-hand side. Yeah, if anyone missed this part, it's not going to be a major deduction, just a few points, minor deduction. Okay. Let's move on and look at sheet 3, okay, which is another test case. And in this case, we're looking for 9. So I think most people will probably guess what happens in this case. B will keep moving to the right-hand side until it is beyond, that point. We'll go ahead and trace it. Line 1 is initializing B to 0. Line 2 is initializing E to 4 minus 1, which is 3. Then we go to line 4. It's basically the same stuff as last time so far. 0 plus 3 is 3. 3 divided by 2 is 1.5. The floor of 1.5 is 1. Then we go to line 5, and then we do the comparison. A bracket m is less than k is false. Because m is 1, a bracket 1 is has a value of 2. 2 is less than 9 is true. Okay, never mind. I was wrong. Okay. Did you guys see the problem? Did you see my mistake? Okay. I did it without actually doing the comparison, without actually looking at the value of the columns, and I was wrong. So in this case, let me just re-explain it. M is 1. A bracket m refers to a bracket 1. A bracket 1 has a value of 2. 2 is less than k. K has a value of 9. 2 is less than 9 is true. So we have to go to line 6. Line 6 is going to update b to become m plus 1. M is 1 at this point. 1 plus 1 is 2. So b becomes 2. Then we are done with the conditional statement. We go to line 10. Line 10 is doing the same thing as last time. A bracket m equals k is false because we already know that a bracket m is less than k, which means it cannot equal to k. But since this is a disjunction, just having the left-hand side being false does not mean the entire thing has to be false. We have to evaluate the right-hand side. The right-hand side is asking, is e less than b? And at this point, e is 3, b is 2. So that comparison will also give me a false. False or false is false. That means we have to go back to line 4 and do it all over again. This time we have 2 plus 3, which is 5. 5 divided by 2 is 2.5. The floor of 2.5 is 2. So m becomes 2 in this case. We go to line 5. A bracket m is less than k is also true because m is 2. A bracket 2 has a value of 4. 4 is less than 9 is true. That means we go to line 6 again. Line 6 means we have to update m to become, we have to update b to become m plus 1. M has a value of 2 at this point. 2 plus 1 is 3. And b is now updated to 3. Are there any questions so far? No? Okay. Then we are. Then we go to line 10. Line 10 is false. The first condition is false. The second condition is still false because at this point, b and e are exactly the same. Okay, they are both 3 at the same time. 3 is less than 3 is false. So that's why the condition is still false for the last time. We go back to line 4. This time we have b equals to 3, e equals to 3. 3 plus 3 is 6. 6 divided by 2 is 3. And the floor of 3 is also 3. So m is now 3. We go to line 5. We do the comparison. A bracket m is less than k is true because m is 3. A bracket 3 has a value of 8. K has a value of 9. 8 is less than 9 is true. And we move on to line 6. Line 6 wants to recompute the value of b to become m plus 1. M has a value of 3 at this time. 3 plus 1 is 4. So we update b to become 4. Then we go to line 10 again. A bracket m equals k is still false. However, e is less than b is finally true, which means the entire disjunction is true.
Sure.
Then we get out of the loop. We go to line 11. And on line 11, we evaluate a bracket m equals k, which is false. So f, once again, is updated to false in column G. Any questions about this part?
We're doing line 10.
Sorry?